Hi, in this lecture we'll take a look at some discrete math functions that are available within MATLAB. Let's start with a function called factor. Return the factors that multiplied together will give you x. For example, let's say if you put x equal to 120, then factor of x will return 2 and 2 and 2 and 3 and 5. So 2 into 2 into 2, 3 into 5 should give you 120. Factorial of n is giving you this product of all the numbers starting with 1 all the way up to n. So if you say factorial of 4, you will get the answer 1 into 2 into 3 into 4 equals 24. Rats is a function that converts any number x into its form of a fraction. So if you say x is equal to 3.14 and you say y is equal to RATS of x, then MATLAB will return 314 over 100 is equal to 157 over 50. So it will return 157 over 50 as the answer. Primes of x will list all the prime numbers that are below x. For example, if you say primes of 5, you will get 2, 3 and 5. So you basically, if you say y is equal to that, then y will be 2, 3 and 5. Each prime of x is a query that answers whether or not the number x is a prime number. So this answer would be if you say y is equal to is prime of 5, it will return 1 if x is prime and 0 if x is not a prime number. Now we'll talk about some problems involving permutations. For example, how many ways can m objects be selected from n objects? As an example, you want to pick a captain, a goalkeeper and a center forward from a class of 20 students. So in this case, the order in which you pick is important. So the number of ways in which you can pick a captain can be picked in any one of the students, 20 students, so 20 ways. And then you pick the goalkeeper. After you pick the captain, you only have 19 people left, so you have 19 ways in which you can pick the goalkeeper. And the center forward you can pick from any one of the remaining 18 students. So total number of ways in which you can pick these 3 team members would be 20 times 19 times 18. So that's the answer. If you want to generalize, so the question is, want to pick m objects from a set of n objects in which the order matters. So in this case the answer is, so this can be represented using the symbol n permitted m, npm, and the answer would be n into n minus 1, n minus 2, all the way up to n minus m plus 1, which can be simplified. I'm going to add some additional terms, n minus m, n minus m minus 1, all the way up to 1, divided by the whatever I added in the numerator I must also add to the denominator, so that they will cancel out. So the numerator is simply n factorial now, and the denominator is n minus m factorial. So in MATLAB you could say the answer is factorial n divided by factorial n minus m. Another type of questions often asked is combinations. How many ways can m objects be selected from n when the order does not matter? So it's like asking the question, pick 3 soccer players. We haven't specified what positions they'll play, just 3 soccer players from a class of 20 students. So this is called combinations, and so we recall that we can pick the first player from 20 in 20 ways, second player in 19 ways, third player in 18 ways. Because there are 3 players, they can be arranged in 6 different ways. So 1 into 2 into 3, so that gives you the 3 factorial as the answer in the denominator. So the denominator represents the 6 different ways in which the 3 players can be arranged. So in general, we will represent this as n combination m, and that will be written as n factorial over n minus m factorial divided by m factorial. In MATLAB there is a simple function to do this. It is called n choose k, and you have to provide n and m, and the answer y would contain the number of ways in which this can be accomplished. That concludes this lecture. Thank you.